Negative exponents are frowned upon in math. So in order to make them positive, we move them into their reciprocal location within a fraction. So if I have a to the negative x, that is equal to 1 over a to the x. And 1 over a to the negative x is equal to a to the x. Some might ask why I would do that, or like why does it work? Just to show you off on the side, using the additive law. If I had a to the negative x over 1, if I multiply both the numerator and denominator by a to the x, my numerator becomes a to the negative x plus x over a to the x. Well, a to the negative x plus x means 0, and anything to the 0 power is 1, so a to the 0 is 1 over a to the x. Similar theory, but I'll go through it just to reinforce the above. When we have a to the negative x in the denominator, I don't want that. So I'm going to multiply the numerator and denominator by a to the x. Now you might say, why that? A to the x over a to the x is 1. So it's like multiplying it by nothing. You're just keeping it the same. When you multiply anything by 1, it keeps its identity. Numerator becomes a to the x. Denominator becomes a to the negative x plus x. Negative x plus x is 0. Anything to the 0 is 1. And so I have a to the x. Well, let's apply that now. If I have x to the negative 1/3, I would then take the base and the exponent, move them to the denominator, and make them positive. And I will do the same on here. I have 1 over x to the 1/2. I can do the opposite of that when they're the denominator. I just move them to the numerator. Technically, that's y to the 1/2 over 1, but we don't write that. We just write y to the 1/2. Then if you have x to the negative 2/3, that would become x to the 2/3 over 1, or just x to the 2/3. This is a little more complicated because I have numerous letters now. I have many powers. This power is okay as is because it has a positive exponent. Leave it in the numerator. This power has a negative exponent, therefore it moves to the denominator, and you make the exponent positive. This power has a positive exponent, so I leave it in the numerator as is. Now I have all positive exponents. I am done for now. Sometimes you already have a fraction, so I look at each power. This power is already positive. It's okay in its current location. This power is negative, so I move it to its new location. This power is a negative, so I need to move it to its new location in the numerator. And I am done for now. So let's apply some power to a power, additive law, and the negative exponents. This fraction becomes x to the negative 3/2 y to the negative 6th. Due to the power of powers, which says multiply your exponents. For the same reason, I get x to the first, y to the negative 1, because I'm multiplying 2 times 1/2 and 2 times negative 1/2. From here, you might want to make the negative exponents positive. I don't. I like to first use the additive law, get it down to 1x and 1y before I start flipping locations. So if I combine my x's, I get x to the negative 1/2 by adding the exponents using the additive law. And my y's, I get y to the negative 7. Both of those are negative exponents. In order to make them positive, I put them in their opposite location. X to the 1/2 is negative, so it goes to the denominator. The second power is also negative. It goes to the denominator. I need a placeholder of 1 in the numerator. Again, I'm going to use the power first to get rid of the outside exponent. After I use the power of powers, this is 1/2 because that's a 1, I'm going to use the additive law to get it down to 1x and 1y. Negative 1/4 plus 1/2 is 1/4. And 1/6, my common denominator is going to be 12. So I get 2 twelfths minus 3. So 2 minus 3 is y to the negative 1/12. This is a positive exponent for this power, so I'm going to leave it where it is. This is a negative exponent in the power, so I'm going to move it to the denominator and make it positive.